Here is some good information that will help you decide what type of measurement tool you're going to use to measure the distance. Remember, when we do a survey, one of the main things we want to know is the distance from our survey point or the instrument and the point on the ground that we're trying to measure. So if we're using a surveyor's transit, we already have something that's giving us a rod reading, right? And we'll get the angle of the measurement from east or north, whatever you've set up on. We'll get that angle from the instrument. And so we have the elevation and we have the angle that'll help us position it, but we don't have the distance to the rod. So we have to measure the distance from the transit to the rod. And how do we do that? Even if you're using XY from some point. So there's a few ways to do it. One real common way is you use a little wheelie thing. I'll show you a picture of that later on. But you use a wheel and you just put it right along the ground. Here, let's go ahead and go. And it just travels, and it's a wheel, and it measures every time it goes around, you know, the diameter of the wheel, and it just goes click, 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 and it gives you a measurement. And unfortunately, though, if the ground is not perfectly level, we're measuring the distance along the ground rather than the straight distance to get the position. And so in this example, I've positioned my rod exactly 40 feet away from my site. And as I drew the ground on this, I came up with a length measurement of 40.48 feet. So that's off by close to half a foot, 6 inches. And so if in your survey that's good enough, then that's just fine. But if in your survey you better be closer than half of a foot, or 0.5 feet, 6 inches, then that really won't work. You need a nice level surface to use the wheelie thing if you're trying to get an accurate distance from one point to another in a straight line. There are many, many cases where you want to actually know the length of the ground, and the wheels are excellent. So another thing people do is they put a tape right down below the site, and they get a tape measure, and they just stretch that thing out and take it to there and get the reading. And you know, there's always a little bit of sag, or maybe it goes over a bush or something like that. So just as an example, this is a sag in a tape with 3 inches of sag. So I put 3 inches of sag. Here's perfectly level. And I've got my tape, and I'm pulling on it. If I pull too hard, and it's a vinyl tape, I'll actually stretch it and get a bad reading. If you're using a chain or something like that, it's much stronger, or a metal tape. But let's say I've got a vinyl tape, and I take it, and I have 3 inches of sag. Well, I will get that measurement then as 40.01, much, much closer than 40.48. It'll be 40.01. And up here I've noted that 0.01 feet is about 1/8 of an inch. So I'm going to get a slightly too long measurement. And again, if your job doesn't require that it's perfect, then that's good. But you can imagine that's just on 40 feet. If you're at 100 feet or 200 feet or 300 feet, these things all multiply, and they get these numbers that it's off get pretty big. This is on a pretty small distance, a small distance of 40 feet. That's like the distance across a street. So it's not particularly big. Maybe it's the difference from the back of a residence to a fence line. That's pretty big for that, but not to the front. Okay, so we've got the wheelie measurement. We've got a tape measurement. Those are both giving us probably measurements that are a little on the long side. And then, of course, there's lasers. Now, you have to have a good, powerful laser. A good outdoor laser is $150 to $200 or more depending on if it's got a level on it and how, if it's got a compass on it and a level on it. You can get a very, very nice laser that costs a little bit more. But if that laser is setting perfectly level, and I've got a little reflector, and let's say my reflector is about 1 inch thick and I lay it up against what I want to measure, then I'm going to get a measurement that's short by the thickness of the reflector. So if it's a 1 inch reflector, I'm going to measure 39.917. And of course, then if I know the thickness of my reflector, well, then I can just add that back in, and lasers are as close as you can get if, again, they're level. Now, some of the problems with that is if there's a tree in the way or a bush in the way or something like that, then you might have to take multiple measurements and do a little bit of layout with it. It's not always easy to get a perfectly level laser measurement of where you want to go. And then sometimes you're just off. It's not perfectly level. And so you can imagine that this upper line here, I'm going to get, instead of 39.91 as my reading, if I'm off by 1/2 degree, I'm going to measure 39.92. Okay, and again, so that's going to be off by about 1/8 of an inch. So you're level, and the farther I go, the more it's going to be off, right? The farther I go, the more it's going to be off at a given angle. So when you're using the lasers over a short distance, the level is not particularly important. If 1/8 of an inch is good for you, which in many, many cases it can be. But if you're going a long distance, you can start making some significant errors with being out of level with your laser. And so then there's one more way. It's called a stadia. It's a tube. It's what you're looking through when you look through the sight, and you see the big crosshair, and above the crosshair there's a little line going across, and below the crosshair there's a little line. Those are called stadia lines, and I'll show you those in another example. But by using a stadia, those lines are set apart at a very specific angle, so that those are measuring a half angle up and a half angle down for a total of 1 degree. As an example, you read your stadia to tell you what it is. Now, sometimes the stadia, instead of giving you the angle, gives you a factor, which is really nice, because then it's just a multiplication and you don't have to do much math. They just give you a multiplication factor. Very, very nice to do. Okay? And so you'll either read the angle or the factor, and then you'll read on your rod the distance that those two crosshairs show. And if it's a long way away, they're going to show a big number. And if they're very close, they're going to show a small number. And you just use the distance between those crosshairs and the fact that those are apart to get your number. Now, the nice thing about that is it doesn't really matter how level you are, because it's the stadia, the precision of your sight tube, that counts. If both of these go up a little bit, it doesn't matter if both of them go down. So the stadia is a very, very cool method and way to get it. But of course, you need a rod, and a well-calibrated rod. All right? So those are some things. So here's the calculation on the stadia. And you can see that that tangent of the angle can be a fixed number if you know what that angle is. And so you can often, they'll just give you the angle, or they'll just give you this number, tangent of the angle, and then you'll um, get that thing all squared away. Okay, so there we go. That's how you do it. Those are the differences you can make. And so as an example, on this one I got 39.991 feet, so it was off by 0.0, pretty close to 0.01. So that was off by about 1/8 of an inch also. Okay, just as I calculated it out, it was off by just a hair because and that's because of rounding errors. So those are some ways you can do it. The wheelie measurement, if you're not very level, can be off by quite a bit. The tape can be off if you've got sag or if it's going over something. Your laser can be off if it's a long distance and you're not very level, but that your laser really is your best tool if you can invest in a laser. You do need a good, powerful laser if it's going to work during the day. Now, there are other methods also. There's LiDAR that works very well. There's sonar that can work very well. But these are the most common ones right here. And then your Stadia, which is very good because you don't need to be level. All right, there you go. Those are some of your measurement tools.